Hello, good morning or good afternoon. Today we're gonna be talking about our SNA US 6000. This content is about the features, working modes, installation, and status code for troubleshooting. Features, it's gonna be the highlights and specification. This inverter is a multifunctional high-frequency pure sine wave off-grid solar inverter. This is for pure off-grid backup power and also AC couple mode with separate generator input interface, able to control generator and remotely. Um, for monitoring, it can be Wi-Fi or with a SIM card. We call it uh, also for setting and firmware update, support website, and the app is free. Specification. It's an exceptional specification design solely to tackle your power challenges. It's rated 6 kilovolt amp or 6 kilowatts. It has a 2 MPPT solar charge controller. DC voltage is 100 to 480 volt DC. Max amp per MPPT is 17 amp or 4 kilowatts. Its string maximum is 8 kilowatt input. Um, with integrated advanced parallel function, you can parallel up to 16 pieces. For installation, we're going to be talking about the port and LCD interface introduction, installation requirements, battery connect, PV inputs design, generator control, uh, port introduction. Um, this will be the board for communication for battery canvas or RS485. This is for the port communication for parallel. Uh, this is for the gen dry contact for auto start and auto start or stop. This part is the Wi-Fi. This is where you to connect the battery cables, and the inverter. The inverter comes with a load breaker, grid breaker, and gen breaker, and also it comes with a PV switch. LCD interface introduction. Um, there's two light on it. One on the left is gonna be the normal LED, which is green, and then the fault on the right side is will be a red LED. Uh, with grid green solid on, it's working normal. Green flashing. If it's fast, it's a warning. If it's slow flashing, um, it will be a firmware update. Red flashing means there's an error on the inverter. LCD interface introduction. Uh, Number one is where you can find the serial number like that. Mostly is the general information display area. Number two is the PV, output or energy data. Number three is for the battery information and data. Number four is the status or the setting code for the inverter. And number five is the UPS or EPS output information. Number six is the programming and the percentage of AC output and firmware update. Number seven, this is the load consumption for the house. Number eight, this is where the grid and generator information. And number nine is the working modes for AC charge, charge first and force discharge. Installation requirement. Um, AC side, you will need a 25 amp input breaker. The output is 32 amp or 40 amp output breaker. Um, earth leakage, SPD, lights grid inverter. Or also, if you add a changeover switch or like a bypass switch for maintenance. On the DC side, um, you can put fuses. That's up to you. The input and like I said, the input for the MPPT is 120 to 385. This is the MPPT range voltage and 17 amp per MPPT, but the max voltage is 480 volts. You can add SPD, also isolator breaker. On the battery side, you can add 150 amp fuses and 35 millimeter cable, but our inverter comes with it already, so you don't have to. But with places that have a thunderstorm, we recommend you add a SPD on the input, output, and then the PV side. Battery
Hello.
connection.
Hi, Carlos. This is Glenn Wiley from Solar Online, Calgary, Alberta, Canada. How are you?
Battery connection. Um, we recommend to be cautious, not to reverse polarity, the positive and negative. Um, um, if you have a Hina battery is installed, only high 5 requires a dip switch adjustment, while Power Gem and Power Gem Plus do not. For parallel connection with different number of batteries, each battery unit has a unique dip switches. Please refer to the SNA US 6000 and Hina ESS setup manual for more details. Okay, battery communication. This is a sample for Hina battery brand. The communication protocol between SNA 5K or 6K and a different battery various, please choose the corresponding battery code. For example, HANA battery utilize the CAN protocol. Battery code is 1 HANA battery. Um, please check the pin definition where HANA ES use the pin 5 and pin 4. They're talking about the cable, the communication cable between the battery and inverter. PB input design. Uh, this is a sample for series. One string of 220 watts. Both add ups, but amps stay the same. So if you do the math, it's equal to 1000 watts, 152 volts, and 8 amps. Um, like I said, the PB input is 100 to 480 volts DC. Um, Max solar panel series quantities voltage of single panel is 38 volts. Um, it's saying that you can add 12 pieces in series maximum. Max is 4000 per MPPT. Also, the PB negative port should not be connected to the ground wire. And when parallel connecting strings, the number and the brand each string should be the same. Following the principle of series connection first and then parallel. Next one is a parallel example. So this one, it has 8 panels, 2 string of 1000 watts panel per string. So the voltage stay the same, but the amps add up. So if you add it together, it's 2000 watts. The voltage is still the same, 152 volts, and the amp is 16 amp. So the max PV input current per MPPT is 17 amp, and max number of solar panel in series is current amp 8 amp. So one string is 8 amp. So two string solar panel in parallel is allowed, but the current will be limited to 17 amp. It's saying this, you can put more than 17 amp, but the MPPT will only take 17 amp from it. Max input per MPPT is 4000 watts. So if the solar panel is 250 watts, it's saying over here, you can add up to 13 pieces. This is based on the max input voltage limitation, and the max number per string should be 12 pieces. If you need more than 4000 per MPPT, 2 times 8 pieces is suggested. Gen remote control. Implement automatic start and stop using dry contact control. Condition the generator itself has an automatic start and stop function. You can configure the automatic start and stop in the monitoring platform by setting the start and stop for battery SOC or battery voltage. It is recommended that the generator capacity be equal to the greater than the inverter capacity. For single system, the minimum input current should be greater than or equal to 32 amp. The rated power is 7,370 watts. Um, this is the diagram, and this is the setting. You can also do this on the screen to do the programming settings. Next is working modes. First is power backup mode, AC couple mode, and Gen boost function. Power backup mode. Power source is solar, battery, and then utility. Um, PV power is utilized to compensate the load consumption, and when there is a surplus solar energy, the battery get charged. The grid take over the load when battery reach the ungrid end of discharge SOC or volts, or fallen below the start AC charge SOC or volt. So this is if you're on the app or the web, um, this is how you configure the setting. AC first means if you set AC first, it will use the grid to take over the load, and the PB will charge the AC, will charge the battery. Um, yeah, AC charge enable, and then you can either set to according to the time or according to SOC or volt.
Excuse me. Can I ask a quick question? Uh, we upgraded firmware this morning, and
Um,
why would you have to set one of the T1 start time and end times to like 0 start time and 23:59 end time if you're basing the enabling of AC charge strictly on the SOC?
Plan.
Yes,
Can we ask question after the presentation?
of course. Yeah, sorry about that.
Thank you. For setting up configuration via LCD, um, set is on the setting 15, which is AC first time. For AC charge is setting 14. Setting 12 is for on-grid end of discharge, and setting 11 is the off-grid cutoff SOC. On-grid end of discharge SOC means this is when the inverter use um use the grid to cover the load, and off-grid cutoff SOC means this is when the inverter turn off the output on the load breaker when there is a power outage. This mode is most likely it's self-consumption mode because it uses solar, battery, and then last is utility. Next one is battery and then utility without a solar panel. So same thing, this is like for only backup only when there's a power outage. So the battery will operate until it reaches the ungrid end of discharge at SOC or volt, or fallen below the AC start charge SOC. So most likely you set it to 24 hours for the AC first time. So it doesn't discharge the battery. it will only discharge during power outage. If you want to use the grid to charge, of course, you don't have a panels, so you can set according to the time or according to SOC when you want to charge the battery to using grid. So when setting the exact value, when the battery discharges below the value, the system will automatically switch to the utility power to ensure continuous electricity supply. So the 6K, it has a fast switching time. You wouldn't even notice when it switched from battery to grid. Um, if you're setting this on the LCD, AC first time setting is on number 15. Same thing, setting number 14 is the AC charge. The on-grid end of discharge is 12, and then off-grid is number 11. So this mode is for backup only during power outage. Next one is it power source priority is utility, and then battery, still no panels. Um, it's almost the same thing. Battery will discharge exclusively during load shedding or grid power outage. Um, Same thing. It's the same setting as the first one. Next one is AC couple mode. Solar battery and then utility, or they call it SBU. AC couple mode allow building a power grid for a grid tie inverter when the utility is down and allow it to continue generating power. Well, our latest firmware, it support AC couple for SNA 6000. Um, this is how you configure on the web platform. I think you can only do it on the web platform for the AC couple. So AC couple is start bin. This is when the AC couple are resume um after it reaches AC couple and SUC. So it's so for example, if you set it the AC couple and SOC to 100%, if the battery reaches 100%, it's either turn off the AC couple or it use the frequency shifting. If the battery is still 100%, it will turn off the AC couple. And then when the battery reach AC couple is start SOC, this is when the AC couple is start again. So a lot of installer and user use this setting wrong. They usually set it to 95 and then 50%. So what that it means is when it reaches 95, it will turn off the AC couple. And then when the battery drop to 50%, the AC couple will start again, which is you don't want that. You want the SOC close with the AC start. So when the SOC drop couple percent, I would recommend like 5%. So your AC couple will help to charge the battery again and the load. So yeah, a lot of installer and user use this um setting. Like I said, set AC couple and Evo. Set the start SOC based on the battery control way. Set stop SOC. Um, on the grid tie side inverter, make sure you enable the frequency response mode. So the grid tie inverter could respond to the frequency shifting control from the SNA 6000 to avoid overcharge issue. Um, Gen boost function, power source. Power source priority is generator, solar, and then battery. Uh, Gen boost function enable the PV and battery to work with the generator together when the generator power is insufficient to handle the load. So it means if the generator power is um if what do you say? If the load power is higher than the generator output, the inverter will help using PV or battery, so the generator doesn't get overload. It doesn't overload while it's running. For example, if the gen power is uh let's say 4 kilowatts and the load is 6 kilowatts, so what's gonna happen is the generator will provide 4,000 watts and the inverter will provide um 2,000 watts from either PV or battery without overloading the generator. Um, like I said, if you use this function, you can enable it. You can set the max generator input power based on the capacity, and then you can set the start SOC or voltage. You can also set this on the LCD. It will be on the setting number 30 to enable, and then setting 18. This is the gen in, and setting 25 is the generator charge limit. Um, Status and codes and troubleshooting for error codes. Um, um, this is the status code. Um, yeah, you can look on this. It should be on the manual, the status code. It tells you what it means. If you see this on the top of the inverter, and the next one is the troubleshooting. When there's an error, you will see this sad face, and it says fault, and then the number. So the troubleshooting code will be on the manual too. So if you see this number and it says 21, so this is PV voltage high, which means it asks you to check the input of the PV is higher than 480 voltage. And then warning, if it's warning, you will see still the normal, but like a warning face and then the number. So the difference is the code. Error code is CE, and then warning code is W. But on the LCD, it will not show W or E. It will only show you the number. So for warning Warning, the phase is next to the normal phase, and fault, the normal it doesn't show up. If you have an error, it will cut off your output, your load output. Yep. Thank you for joining today.